Welcome back, everybody, to What Do You Know with Nick and Devin. I am Devin.
And I'm Nick.
Thanks for being here, everybody.
That was very like Delilah, the light. Thanks for being here, everyone.
Okay, but she gives some unhinged advice during Christmas time.
I have not listened to Delilah since I was probably in middle school, so I can't even imagine. First of all, that she's still on the air.
Yeah, I think she's a robot by now. She has to be.
This is a continuation of the Max Headroom situation. Yeah, okay, perfect.
Yeah, she hit her head
right
on a Delilah street.
And like, now AI's too good. We have to keep her.
Right.
Yeah. She's got to be, I mean, I don't even know how old she was when she started, but I assumed that she was like in her 40s when she started. So now she's what, in her 60s maybe?
I'm typing and figuring out how old she is. Oh, she's also an author. She is, what'd you say how old she was?
I think she's 62.
Oh, you are so fucking close.
What is
63.
Ah, damn.
Damn.
Although Price is Right rules, I'm the closest without going over. Not that
That's
anyone
true.
was competing against
Yeah,
me.
not that anyone else guessed.
But
But
what did she author? I feel like she's very like Chicken Soup for the Soul sort of author.
I imagine. Hold on, let me open up her Wikipedia page where all the
Okay.
best research happens.
Perfect.
Oh, books. Here we go. Books. She has 4 books.
Okay.
Titled Love Someone Today, Encouragement and Inspiration for the Times of Our Lives.
Oh.
That came out in 2002.
These are the days of our lives.
Her sophomore book was Love Matters.
Okay.
Then in 2012, we have Arms Full of Love, Inspiring True Stories that Celebrate the Gift of Family.
Oh.
And her final book came out in 2018, One Heart at a Time, The Inspiring Journey of the Most Listened to Woman on the Radio. I feel like that's more of a biography.
Memoir of sorts.
Yeah. Well,
Interesting.
if you're looking for books for your book club.
How many people do you think she's actually helped?
I
feel Delilah made me do this. And
I
it
think
changed
there's
my
kind of
life.
like a cult following for her.
You think so?
Absolutely. Like, okay, so next, you have a lot of homework. Well, you have one homework assignment that's far in the future.
Okay.
Listen to 93.9 during Christmas time when the Christmas music comes on.
Okay.
I don't know if she does it normally throughout the year, but that's the only time I ever listen to Delilah.
Okay.
It's like driving home from holiday parties.
Mm-hmm.
And she'll have people call in and be like, Delilah, I have some issues at home that like my husband is just drinking all the time and I just don't know if I can love him anymore. And Delilah's like, listen, I've been through this like 20 times, divorce them all. You got to take care of yourself. And like she gives like that kind of advice. It's wild.
How many marriages has she been in?
Oh, fuck. Hold on.
This is now, what do you know about Delilah from 93.9? And for those of you who are not in Chicago, because I feel like it's a Chicago thing, right? Or is she national?
I don't know if she's syndicated. She might be syndicated.
I mean, I'm sure.
But she's always on 93.9 around here.
Right.
How many? Oh, she's only had 2 spouses.
Oh, okay.
So I may have exaggerated.
Is she? I've never seen her. Is she exactly what I think she is?
Yeah, hold on. Let me pull up a different window so you can't see the topic that I'm going to talk about today.
Oh, okay.
As a different tab.
Yeah. And in case you also don't know, we never know what the other one is going to be talking about.
Oh, right,
Yeah.
right. It's
Up
always
until
a
it comes out of their
surprise.
mouth. Yeah.
That's what she looks like. Yeah.
It's
It's just
on.
like a white woman.
Yeah. Picture any white woman.
Right.
Yes.
Like if you had to do like Webster's definition of white woman, the picture would be Delilah.
Yeah, that's fair.
There you go.
I give that to you. I am surprised. I always thought Delilah was a stage name.
As far as we know, her birth name is Delilah.
All right.
As far as the lore goes back.
I feel like you just don't meet a lot of Delilahs.
No. Well, she was born in 1969, so I
Well-
feel like there's also Hey There, Delilah from Plain White Tees.
Thank you. I was really trying to figure out the name of the band, and then I couldn't think of it, so I was trying to make a joke. So thank you for bringing that.
Yeah,
up.
no problem.
Yeah,
It was at one point probably a song in my MySpace profile. So
when I open your profile, it's Hey There, Delilah.
yeah,
I can
I
see
was
that.
a real edgelord. All right. Well, speaking of edgelords, let's get into my topic.
What did you just call yourself?
An edgelord?
Edgelord?
Yeah.
What is that?
You look it up on your own time.
Okay.
All right, my topic
We'll
for
come
today.
back. Is it about edgelords?
No,
I
not
feel like
at all.
I'm saying this and you're chuckling to yourself because I have no idea what this is.
I mean, it's funny to
Uh-huh.
me. I'm just surprised you've never. Well, we don't run in the same circles.
That's very true. All right, we'll come back to this.
Anyway, so my topic, nothing to do with Delilah, Christmas music, or edgelords. So I would love to ask you though, have you ever been to a national park?
Oh, I feel like yes. I've been to
Maybe, I don't know.
yeah,
Oh, yeah, definitely.
yeah.
Okay.
The dunes, of course. That's a national park.
I think so. I forget that those are under the umbrella.
I mean, it's not a pleasant experience. There's so much sand, but you could go and see
Okay,
it.
Anakin.
I hate sand. I've also been to the Grand Canyon, which I believe is a national park.
Yes.
And I think that's it, honestly. But I've always wanted to go to Yellowstone.
Yeah.
That's it.
Okay. Did you figure out where we're going with this topic?
Are we going to Yellowstone?
We are going to Yellowstone.
Hey, okay, cool.
So
Does Kevin Costner come in? Come on in.
No, not at all. Sorry to disappoint everybody.
That's
I've been to a few national parks. I actually turned 2, I believe, at the Grand Canyon.
That's cool.
And I'll probably be corrected in the comments. Gail Pryor's always in the comments,
Yeah,
so I'll
she
see
is.
you there, Mom. But I believe I turned 2 at the Grand Canyon.
And was it a fun experience? Do you remember the experience?
No.
Okay. Have you ever been back to the Grand Canyon?
I have not, but I would like to.
Yeah. Would you
It
hike
might
it?
have gotten bigger. I would love. I don't know if I'd hike it. I'd ride a mule down though. That'd be so fun.
That seems. I don't know about that.
All right.
I get very so. I'm like a bigger guy, like on a mule. Like,
Yeah.
I'm sure they're fine.
Yeah,
But it
they're
feels-
meant to carry you.
I know, but I feel bad. Like you're going down these like rocky terrains, like
yeah.
down to the foot of it. And I'm like,
I think they have
let's
fun
go.
with it.
Yeah, okay.
Oh boy, let's
If-
go.
Yeah, they're like, if I could choose a life of leisure at the
Right.
bottom of this canyon or carrying your fat ass up and down it, yeah, I'm sure they pick the latter.
Maybe. Once I figure out how to talk to mules, I'll let you know.
Please get back to me, Snow White.
All right. So, my topic for today. What do you know about the Yellowstone supervolcano?
Ooh, I know it's gonna destroy the Earth. That's it.
Okay, cool.
Is it? I don't know. I just know that it's massive and at any moment could erupt. Maybe.
Maybe.
Okay.
We'll find out through this discussion.
Yay.
So, first off, one, Yellowstone National Park, for those of you who don't know, not in the United States, is a pretty large national park in the western United States, Wyoming, Montana, that area. It's beautiful. A lot of great things there to go see.
Gorgeous.
And I would also like to first define what is a supervolcano.
Oh, okay.
So I think that's kind of needed for context.
Thank you. Yes.
So this phrase was first used in a volcanic context in 1949.
Oh.
And I'm about to describe what may seem like a definition of a supervolcano.
Sure.
But it's kind of an unofficial term used loosely. Like
It's like a colloquialism almost.
Yes and no, because like it's used in the science world, but like no one really knows like definitively what a supervolcano could be.
Interesting.
And like there are boxes that you have to tick to be under a supervolcano umbrella,
Sure.
but like it's everywhere else is like, yeah, it's so loosely defined. Like, what even is a supervolcano? I was like, well, I have these things that define a supervolcano, so I
It
feel like we
sounds
have a
like-
definition.
Sounds like criteria
Right.
have been made to fit into the box.
But here we are.
Correct.
So just given that little
Okay.
wording.
Thank you.
So the term supervolcano describes a volcano that has had an eruption with an 8 on the VEI, or the Volcanic Explosivity Index.
Has had it or could have it?
Has had.
Oh, so this has erupted previously.
Yes. So
Oh.
I think part of why it's such a wish-washy definition is because you have to determine that the eruption was so massive,
Yeah.
and there's no way to predict how big. At least I think, I could be very wrong.
Yeah.
I don't think there's a way to predict how big an eruption could be, or at least have a solid idea. You could be like, this might be anywhere from this small or this big of an eruption, but I don't think there's any like set way of being like it's gonna be this fucking big.
Yeah. I feel like I've had this conversation before. It's right there. It was right. I had to. I'm sorry.
It's fine. It's fine.
Okay,
I don't think there's anything that's too lowbrow for our
That's
podcast.
Fair. That's fair.
Because I actually have a lowbrow joke later anyway.
Yes.
So
Okay. Perfect.
This is the scale, the VEI, Volcanic Explosivity Index, is open-ended at the moment, with an 8 being the current greatest value. So an 8 being the biggest we've seen.
Okay.
Or at least been able to measure through geological science. 0 is for non-explosive eruptions. They typically have less than 10,000 cubic meters or 350,000 cubic feet of fragmental material ejected by the eruption, or tephra for short.
Oh.
TEPHRA.
Excuse me. I was going to say it with an F, so I appreciate that.
I got you. 8 is for supermassive explosive eruptions.
Land it.
These can eject as much as 1 times 10 to the 12th cubic meters, or 240 cubic miles of tephra.
Okay.
So that's 1 with 10 zeros of cubic meters. Yes.
So do you know what Mount St. Helens was on the scale?
I
Comparatively?
do.
Do we get into that? Sorry.
Yeah,
Okay,
no, I
we'll wait.
mentioned some eruptions that happened in Yellowstone, and I compare them to Mount St. Helens.
Got it. Okay.
So sit tight.
Heard. Sitting.
8, supermassive, 240 cubic miles of tephra with its eruption column reaching as high as 20 kilometers or 66,000 feet up into the air.
Oh my God.
Crazy huge.
Yeah.
So this type of eruption only has to happen once, kind of like I mentioned earlier, at some point in time for the volcano to be classified under the supervolcano umbrella.
Got it.
So once it happens once, you're like, yep, that's a supervolcano.
Sure.
Whatever that means. Anyway, so something exploding at that magnitude, at an 8 on the VEI, can have long-lasting effects on the surrounding area.
Okay.
To an area of like miles and miles from where the point of the explosion happened.
Yeah.
So massive areas could be covered in lava and ash. Climate change happens, potentially triggering another ice age, and can cause certain species to go extinct because of the ash cover or the lava flow.
Yeah. Okay.
Just killing anything that happens to live there.
Yeah, that's fair.
So the last VEI-8 eruption, a supervolcano eruption, happened 26,500 years ago in New Zealand. That's the most recent one.
Okay.
Now, I want to put a little asterisk in this note.
Okay.
Because I'm going to be saying a lot of dates that are like thousands and millions of years ago, but to our tiny little human lives, that's so long ago. But in terms of geological time, that's an instant.
Yeah.
So just put your head in that
Well,
space.
what's older, sharks or the North Star?
That's a fun trivia fact. I don't know. Is it the sharks?
Mm-hmm.
Wow.
Isn't that crazy?
That is crazy.
Mm-hmm.
Crazy?
It's crazy cupcakes.
Crazy cupcakes. All right, we'll put that on some merch.
Yep.
There'll be some sweatbands.
Done. Done.
Queasy cupcakes. All right. So last VAI, New Zealand, 26,500 years ago. These are these eruptions are created by essentially the Earth like edging itself for millions of years at a time, and
I mean, You're eventually
Bob
going to
in
have
there.
a big
Bob in
explosion. Yeah. Talking
Right.
about edgelords, you know what I mean?
So magma rises up to the crust, but can't break free. So this pressure builds up and creates a magma pool. No lifeguard on duty. Stupid joke.
So dumb.
All right.
Did you write that in your notes?
No, I didn't.
Okay. I was like, you.
That was off the cuff. So eventually the crust can no longer contain this massive magma pool, and it erupts.
Sure.
happens.
Sometimes it's just gonna happen. It's okay.
We'll get through it
Together.
So these magma pools and whatnot typically develop at hotspots or subduction zones.
Okay.
We're going to define those right now.
Thank you.
Don't worry.
I appreciate
So
that.
hotspots are essentially spots where magma has come up from the mantle, unrelated to the location of tectonic plates. It's just kind of like wormed their way up.
Okay.
And the magma can be shifted or dragged along in relation to the motion of the plates, the tectonic plates.
Okay.
Which might create a chain of volcanoes. So those are hotspots.
Oh, got it.
Chain of volcanoes being like on the islands of Hawaii, and other examples.
Yep. Isn't there like a huge ring of fire over there?
Yeah. Yes.
Is it in the Pacific, right?
I don't know the exact full location of the ring of fire because I think it's pretty massive. Like it goes around the Earth, but I think Hawaii is part of
the ring.
The ring.
Yeah.
Subduction zones are when plates, the tectonic plates of what all the continents and stuff are on, the crust, are grinding against each other, and one layer of the plate like slips underneath the other plate, and so the material of the tectonic plate gets superheated and melts away. And so this process can drive up magma from the mantle as the material from the subducting plate sinks down into the mantle. So it just kind of like shifts and pushes magma up as the plate goes down.
Got it.
Kind of displacing the liquid.
So 2 questions. 1, isn't that also earthquakes?
Yes.
Okay.
Yes.
And then 2, you're telling me that grinding can lead to an eruption.
We've all been there.
Just clarifying.
There are so many more lowbrow jokes than I expected and anticipated in this episode. But hey, bring them all in. We got plenty of room around this table. So the other term, now that we've kind of loosely defined what a supervolcano is, the other term I want to define is a caldera.
Okay.
And why?
That sounds very familiar.
Well, yes, I guess.
Okay.
I don't know.
It sounds like a character.
I don't know.
Okay.
All right.
But continue. What is a caldera? What do you know about them?
So, what do you know about calderas? You're thinking Devin. All right. So, while I'm talking about the Yellowstone supervolcano, while this episode card will say Yellowstone supervolcano, it is actually usually referred to as the Yellowstone caldera. Since, like I said, the supervolcano is kind of a loosely defined term.
Sure.
But also, Yellowstone most of Yellowstone sits within a caldera.
Okay.
So simply put, a caldera is the empty space left after a large volcanic eruption. Some would call it a crater, but it's not a crater. It's more like a sinkhole because you have the chamber underneath a couple layers of the earth housing all of the magma. Volcano erupts.
Sure.
Chamber is empty or mostly empty. And so the structural integrity of the chamber is just kaput, and it can't it can't support any of the weight above it of the remaining earth.
Sure.
And so it just kind of collapses into itself.
Okay.
And that's what creates this divot, what people, like I said, think could be a crater, but it's just the collapsing of the earth on top of itself because it's empty underneath.
Okay.
And so while this sounds like we should probably have more calderas hanging out on the earth, they're surprisingly a relatively rare event because massive eruptions are fairly rare as well.
Okay.
So we only have a few calderas forming every hundreds of years. So for humans, that's pretty rare.
Yep.
Grand scheme of Earth, there might be a lot more coming around. The Yellowstone caldera was actually the largest caldera on Earth until 2019 when and I'm probably going to pronounce this wrong, Apolaki caldera was discovered in the Philippine Sea.
Oh, okay. Oh, it's in the sea.
In the sea, so it's kind of
So
hard
we
for us
get
to
like
find out.
the biggest land one.
Yeah.
That's what I'm going with.
Yeah, so there's probably a lot more calderas formed in the ocean.
Sure.
considering how much of our planet is covered by
Water.
water.
Yeah.
Some say 70%. Some would say.
The scientific community might be part of that.
So what is so important about this supervolcano, this particular one in Yellowstone?
Lay it down.
Well, like I said, Yellowstone, Yellowstone National Park, located in the western United States. It's an incredible and popular tourist destination. Really having trouble with my R's today.
You really are. See that out. It's that tooth.
Okay, I chipped a tooth, everybody. All right, I'm gonna put it out there. I chipped a tooth. It was very small, and I got it fixed. And they just ground down the tooth, and
But how did you chip your tooth?
I sneezed. All right, I sneezed, and it was such a powerful sneeze, or I was just holding my jaw in a weird place that my bottom tooth shot up into my top tooth, took out a tiny chunk. And I chipped a tooth. It's fixed. It's fine. I don't have any speech impediment because of it. It's my first cup of coffee, all right?
Devin's superpower is atomic sneezes. And that's what happens.
It was a pretty powerful sneeze.
Yeah.
That chunk of tooth is just launched somewhere in my backyard.
Gone.
Anyway, back to Yellowstone and my R's. All right, so Yellowstone National Park, Western United States. Incredible popular tourist destination. If you haven't gone, highly recommend. Just don't mess with the bison. You'll wind up on those videos.
Thank you for the PSA.
This supervolcano underneath Yellowstone is actually the cause of the many hydrothermal features featured at the park.
Sure.
Yellowstone actually has more geysers than anywhere else on Earth, with Old Faithful being the most famous.
Yes. I mean, she's old.
And faithful. There are also hot springs, mud pots, travertine terraces, and fumaroles.
Excuse me?
Look those up on your own time.
Okay.
I can't talk about every geological feature. We'll be here for a whole 3-hour lecture of Geology 101.
Pulls down. Lecture board. Yeah.
Gets a beard. Cargo shorts suddenly appear. All right. So a couple years ago, some observations about the caldera came up and that were scientifically fascinating. Geologists were having a fun time with these tests coming up, but the media kind of took those numbers that they found out and sensationalized what they actually meant.
Oh.
So articles and TV shows, especially on our favorite channel, probably History and Discovery, hyperbolized the actual results, concluding that this massive volcano field could erupt any day now, and it was overdue for such a massive super eruption. According to the USGS, the United States Geological Survey, that's a bunch of baloney.
Baloney, they say.
Baloney. Official documents signed by the government. Baloney.
B-O.
So what made the media freak out like that? What made them hyperbolize and sensationalize all of these results?
Yeah.
Because a lot did happen. Like I said, the geologists were pretty excited to get all this data,
Sure.
I'll say. There was a lot of movement happening at the caldera. So between 2004 and 2008, the caldera floor had moved 3 inches each year, which is 3 times greater than any measurement taken since recording began in 1923.
Oh.
So you can officially say, hey, 3 inches is a lot. That's my lowbrow joke.
Is that
for the day.
what you wrote in there?
I didn't write it. I was just thinking
You were
about
thinking
it.
about this the whole time?
At one location, it did actually move 8 inches. So that's that's a lot.
That's massive.
So what else made the media freak out like that? Yellowstone had previously experienced 3 larger explosions at about 2, 1.3, and 0.6 million years ago. So 3 separate massive explosions, eruptions. So some quick maths will tell you that there is about an average of 725,000 years between each eruption. Using that trend, even though the media is saying it could happen any day now, if we take that 725,000 years, we still have about 100,000 years to go before the supposed next eruption. If we use that 725,000 number.
Sure.
But the USGS says that this information is ultimately meaningless for 2 reasons. One, you're basing this average off of 2 time intervals, which you can't really
You need
do.
more than that,
Right.
yeah.
You need more than those data points. And 2, surprisingly, volcanoes don't follow a schedule.
They're not crossing their days off a calendar.
Right. Yeah. They're massive, like, millennia calendars. They have, like, cute dogs on it still.
They're like, I'll put this in my Outlook when I want to put this in my Outlook. Okay.
Right. Now, I don't want to downplay those eruptions. They were massive.
Okay.
The ash from these 3 eruptions, separately and together, covered most of the United States. And even reached up to Canada and Mexico.
Wow.
So massive. It covered everything from California to Texas and Mississippi to Montana and North Dakota and everything in between.
Oh, thank God we're okay.
Yeah,
was
Illinois
like,
just kind of like skirted by.
Part of me, I was like, are we going to have to move to like Maine or something? You know what I mean?
Well, I don't know how big the next eruption could be and
Sure.
cover. I remember those shows being like, it's gonna cover the whole world in ash. It very well could, but
Fair.
like, I don't know.
Right now we're fine.
From those 3 eruptions, we would have been fine. Millions of years ago.
And volcanoes really stick on like a border kind of.
Right. They follow political
They're like,
lines.
we don't have any jurisdiction in Illinois, so we can't quite cross
We're trying
the
to
border.
gerrymander the lines.
Yeah, exactly. Like, whoa, can't cross this line, huh?
So the super eruptions that happened to 1.3 and 0.6 million years ago were approximately, this is answering your question from earlier about Mount St. Helens,
Yes.
were approximately 6,700 and 2,500 times larger, respectively, than the Mount St. Helens eruptions of 1980.
A little bit bigger.
Smidge.
That's crazy.
Yeah.
Because Mount St. Helens was massive.
It was.
Comparatively to our, I think, human lifetime.
Yeah, especially in the United States. Our amount of eruptions aren't that many.
No.
And Mount St. Helens was the biggest in recent history on the mainland of the States.
Yeah.
So to have something being as big as 6,000 times larger than Mount St. Helens is incredible.
That's insane.
And these eruptions actually expelled so much ash and lava that, fun fact, they could fill the Grand Canyon.
Wow.
Another national park.
We just get a really big tube and we just like put it on top of the volcano and then funnel it down.
Right.
Yeah.
You know, if the Grand Canyon eroded away to form itself once, it could do it again.
They can do it again. It'll be fine.
Yeah.
Just go deeper.
Just get the mules out of there.
Just get the mules. They'll work it. They'll carry the ash down to the bottom.
Right. So while another massive eruption like that from previous millennia is possible, it's not probable. And this is me saying that. I could be wrong.
Sure. But per your research.
But per my research, it's not probable.
Why is it not probable?
So in 2013, studies of earthquake data revealed that the magma chamber is filled about 6 to 8%, with more recent reports putting it at about a 5 to 15% of it's filled with molten rock, which is more than scientists had thought, but it is most likely still too small of an amount to cause a super eruption.
Sure. I mean, if you're only at 15%.
Right. So like the chamber is full. It's just 15 at max, most likely. 15% is with molten rock, so liquid.
Sure.
The rest is superheated rock, just not molten yet.
Sure.
There was some research done by Arizona State University, however, done in 2017, that indicated that Yellowstone could reach eruptive capacity in a matter of decades and not centuries. So do with that what you will. I don't know.
Sure. Okay. Well, I assume as climate change and the Earth itself starts to heat, that kind of creates a more rapid effect within.
I believe so. I would venture to guess the same.
Yeah.
Because you're just heating everything up anyway. So like,
right.
Why not heat up some rocks?
So then it's more quickly.
Yeah. So I think that's why the number of the 15%, it jumped from the 8% to the 15%.
So
of the molten
fast.
rock.
Yeah.
And that's not to say either that Yellowstone can't erupt at all. It can still erupt at any time, but it might not just be a massive eruption event.
Sure.
It could just be some lava flow. Like the most recent eruption there was only 70,000 years ago, and it was just some lava flow coming out.
Oh.
So it was just gonna bleh and out. We've been there.
A little pre-eruption. You know what I mean?
Right.
Exactly. My question is though, like Yellowstone's massive.
Yeah.
So, and I think of a volcano, I think of a very like specific like peak, and it has like a little bit that everything comes out of. Is it all coming out of this massive like crater? Basically, what's it called? Caldera? Yeah. Or is it like a very specific point within the park that would come out of?
If I remember correctly, there is kind of like I'm not going to call it a chain, but I'm going to call it a chain because that's the best word I can think of right now. There's kind of like a chain of volcanoes within Yellowstone where it's multiple pressure points.
Got it. Okay.
Where the caldera is so huge was from the previous supermassive eruptions.
Got it.
The caldera was so big that it was able to house all of this magma that was able to erupt and cause what did I say, like 60,000 times bigger of an eruption than Mount St. Helens.
Right.
There's still like some hot spots and other areas that have a magma pool, but I don't think it is just one massive point.
Got it. Okay.
Could be wrong.
We'll find out in a couple of decades.
Right. So we kind of have this danger level coming down from a volcanic eruption.
Okay.
But there's still danger to be had at Yellowstone, and that lies with other geological events. So you have other things to worry about geologically than just volcanoes.
Okay.
Things that could happen more frequently and are more likely to happen than a super eruption.
Yeah.
Like earthquakes. You can't have this type of volcanic activity without having a few earthquakes here and there. Earthquakes, quick lesson, caused by shifts in tectonic plates or other events like volcanic activity, landslides, mine blasts, fracking, or even a nuclear test. So they're a seismic event that generates seismic waves that for the sudden release of energy in the lithosphere, causing the surface to shake or quake. There are actually between 1,000 and 2,000 earthquakes annually in the Yellowstone area. And these earthquakes are actually usually pretty weak, though. They still happen. They can still be dangerous because they can cause rock slides, etc. But the largest earthquake recently, since 1980, had been a 4.8 magnitude that occurred in 2014. Now, I did see a graph in my research of the trend of earthquakes, and if you look at that graph, the trend is going up in the amount of earthquakes happening, but I'm not a geologist, so I'm not going to say what that might mean.
All right, thank you.
I'll let you sleep on that one.
Thank you for quelling our panic.
Hey, anytime. I can't be the only one always panicking.
Yeah. So we'll bring you into this with me.
Yeah.
Thank you. Going down with that ship.
So the other thing that you have to actually worry about is hydrothermal explosions.
Excuse me?
Hydrothermal explosions.
Thank you.
Yeah. So these occur when superheated water with temps as high as 250 degrees Celsius experiences a sudden reduction in pressure. Now, water normally boils, unadulterated water boils and becomes steam at 100 degrees Celsius. But under pressure, that point rises. So under the pressure of earth and whatnot being underground, your pressure is going to increase. So you start to boil at 250 degrees Celsius.
Okay.
So this causes, once there's the sudden reduction in pressure, that causes the water to change from liquid to steam rapidly, super fucking rapidly, which in turn causes an explosion of water, steam, mud, and rock debris.
Oh, okay.
This change in pressure can happen from any seismic activity, like earthquakes and volcanoes, erosion or fracking as well. And these explosions can cause some changes to the terrain, but not as of like an extinction level crisis as like a super eruption could do.
Sure.
But they can toss debris to create new landscape and form craters around.
It's still pretty impactful. Yeah.
Right. You could still die.
Thank you.
So the largest hydrothermal explosion actually created a 1.5 mile crater in Yellowstone. And that happened 13,800 years ago. And that crater, that area became known today as Mary Bay. So you could go see it there.
Okay.
Now, the USGS believes that an earthquake caused this explosion when somehow they found this out. I don't know. I think it's crazy that they were able to pinpoint it down to this amount of numbers. But the earthquake caused this explosion when 77 million cubic feet of water was displaced due to the quake, creating massive waves, uncapping a geothermal system, fucked with the pressure, and boom, it exploded.
That's insane.
Right. And these are, so like these hydrothermal explosions, we have all of these hydrothermal features at Yellowstone. So there's a lot of water coming into the park from the mountains. They're melting the snow caps up there, glaciers, old glaciers that have melted or moved away, causing water to come in. You have a lot of underground water there that could potentially explode at any time.
Got it. Okay.
So my final little tidbit here, will Yellowstone erupt and cause dramatic change to the climate, starting another ice age?
Yeah.
That's the big question on everybody's mind. My answer is no, with a big old question mark.
And a shoulder shrug.
Yeah. It's just the shoulder shrug emoji. I'm going to say, my professional opinion, most likely not within your lifetime if you're listening to this in 2024.
Yeah. Fair.
And I'm also going to tell you and remind you that someone much smarter than us is monitoring the situation.
I mean, we are 90 seconds to midnight, so just add this to that, and we're fine.
Done.
Yeah, exactly.
The fun thing, though, is that NASA proposed a project in 2017 to drill down into the magma chamber and cool it off using water at high pressure.
Can that work?
Well, supposedly.
Like, why don't we just freeze it?
Right. Just put a bunch of ice cubes down there.
Like, what do you want?
So supposedly this could cool the chamber by 35%. Stalling any type of eruption.
Oh, wow.
And then the energy released from the cooling process could also be used as a geothermal power source to, power your homes.
We love sustainable energy.
The fun part is that this just costs a pittance of $3.46 billion with a B dollars.
Wait, 3.46 billion?
Yeah.
Oh, that's not bad. When I think about the U.S. budget,
that's
$3.6 billion dollars is not
those,
that much.
Yeah. I guess one of those assholes is like making those in a day at this point. So
truly.
It's fine.
So I think we're okay. We're like, you can write it off if you just apply it. Yeah.
Right. However, JPL, Jet Propulsion Laboratory, you might remember NASA and JPL from our Artemis episode. JPL is worried that drilling into the top of the chamber could actually trigger the eruption. So maybe we consider different options. Kind of like popping a pimple and it just blows up.
But I wonder if you can go down to the side of it.
I don't know.
Do you know what I mean?
I guess.
Like, I feel like we shouldn't just be like,
here's the top of it. Pop.
If we can't go to the top, then that's it.
Right. So I don't really know what's going on with that project.
Sure.
But it seems that people with some doctorates are not as concerned as everyone else.
Well, I feel also if we're at 15%, we have some time. I mean, I feel like if we start getting into like the 40% range,
Right.
maybe we start to look at what that could look like. But
Maybe
it's
we
nice
put a nice
to know,
machine down there, a little Slurpee machine down there.
Sponsored by 7-Eleven.
Uh-huh.
I feel like I could see that, where then
Yeah.
we're like, all right, let's actually start to see what this looks like.
Right.
At only 3.6 billion, so.
It's 0.46. It's cheaper than 3.6.
Oh, see, we're already saving money. And I got a coupon.
Perfect. Well, that's all I have for you today. Thanks, everybody, for sticking around and listening to this, what I thought was going to be a lot more scientific, but it just turned out to be a bunch of dick jokes. So
Hey.
thanks for hanging out.
That's our show.
Thanks for subscribing. Thanks for listening. You can certainly follow us on all of the social media platforms at WDYK_podcast.
Good.
DM us with any of your, volcano theories. Did you guys watch Shark Boy and Lava Girl? Let me know. And that's
Were
all
you
I
Shark
got.
Boy or were you Lava Girl?
Well,
You'll find out next
You'll
time.
find out next time.
Well, you know, Nick and Devin.
okay, bye.
Bye.